All right, so today we're going to be in 4.8 and we're going to start graphing polynomials. So the first thing that you need to know is we're going to talk about end behavior. Okay, so end behavior is really important so you can figure out where to start your graph and where to end your graph. Okay, so end behavior, we have a couple different options. So remember, a polynomial is something to a degree. It can be the first degree, second degree, third degree, fourth degree. So what does this all mean? Well, if we have a positive even power, which means my base is positive, this is the highest power, the highest degree. If my highest degree is positive in front of the x and it's to an even power, that means my end behavior are going to be up, up. So if we're reading a book from left to right, we're going to start up and we're going to do something in the middle and end pointing up. Okay, if it's a negative x to an even degree, then we are going to be, remember, a negative flips it, so we're down, down, which means we're going to start down here and we're going to do something in the middle and end pointing down. What happens when it's odd? When it's odd, think of a line. So if I have a positive to an odd power, for example, y equals x, what's that look like? It's uphill, it's positive, which means we start down, something happens, and we end pointing up. We have opposite ends. If we have a negative x to the odd power, what do you think happens? It flip-flops, which means we start up and we end down, just like a negative line would show. Now, how do we know how many x-intercepts we have? That's also with the degree. So if we have a power of x to the fifth as the highest, then we would have at least 5, or we would have up to 5 x-intercepts. Now, are all of those intercepts going to be real numbers? Maybe not, maybe not. Some of them could be doubles, right? So how many zeros? How do you know? It's the number of the highest power, or the degree, the highest degree. Okay, so if I have y equals x to the third minus 4x plus 2, what's my highest degree? X to the third, so I would have 3 x-intercepts, which means that graph could potentially cross 3 times. Now, we do have a couple strange zeros. So this one you're going to need to know eventually as well. Let's say we have a double root, or we have a triple root. A double root, you need to know that it bounces. Okay, that means if my double root, let's say we have the graph x minus 1, and x plus 3. Well, that means if I set all those equal to 0, I have x equals 1, 1, and negative 3. So a double root at 1 and then a root at negative 3. So at 1, which is right here, this guy is a double. So what does that mean? That means it bounces. So whatever the rest of the graph looks like, whatever it is, when it hits that double root, it's going to hit it and come right back off of it. It's not going to go through it like I did at negative 3. Okay? A triple root flattens, or it slows down to go through it. So let's say we have a triple root. Let's say we have the graph, let's just do f of x equals x to the third, which would give us a triple root at 0. If I set that equal to 0, I would have x equals the cube root of 0, which is 0, 0, and 0. Okay, well, what happens? At 0, what would we do? We have a positive x to the third, so I'd start down, end up, which means I'm going to come up and I'm going to flatten a little bit and then keep going. Okay, so it also, if I have multiple roots, I might go through them, and then maybe I flatten here and then keep going. Okay, so that's a triple root. So that's kind of how your shapes work and your end behaviors work for graphing polynomials.